So this is our trig functions and angles number 2. And what we are looking at today are the 6 trig functions, or trig ratios. So all of this is right triangles today. So we're going to label our right triangle with the names that we call the sides in reference to a specific angle. I'm going to put the angle down here at the bottom. Does anybody remember what the side is called that's across from the right angle? It sounds like a large animal.
It says where?
Anybody know now?
Hypotenuse.
Yeah, hypotenuse. I always think about hippopotamus when I hear that. So our hypotenuse is what's across from our right angle. It's always the longest side as well because it's across from the biggest angle. Okay, and then the other 2 sides, we name them in reference to whatever angle that we're talking about at that specific moment. These 2 will change if you were looking at the angle at the top versus this angle here. So we call the other ones opposite and adjacent. Yeah, so if we go straight across, that is the opposite side. The one that is right next to it is the adjacent side. So opposite is across from theta or whatever angle we're referencing. Adjacent is next to it. Hypotenuse is always the longest side that's across from the right angle. So we're going to write down our 3 trig ratios that you already know, and then I'll introduce the remaining 3 from today. So we've got, remember, sine, cosine, and tangent. Anyone think they remember the ratio? Sine is what over what?
Is it opposite over adjacent?
It's close. It's opposite over hypotenuse for sine. Cosine is
adjacent over hypotenuse.
Yep, and then tangent is the opposite over adjacent. So if you didn't ever learn this is how I remember it. So catoa, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and our next 3 are just the reciprocals of our original trig functions. So I'm going to put their abbreviations, but then underneath I'm going to actually spell out what it is so that you know. So you're not calling it like CSC or something. So we have, this first one is cosecant. And it is just the opposite or the reciprocal of sine. So it is hypotenuse on top and opposite on the bottom. The next one is secant, which is just spelled secant. And it's the reciprocal of cosine. So the hypotenuse is on the top, adjacent's on the bottom. And the last one is cotangent, which is the reciprocal of tangent. Okay. So if you know sine, cosine, and tangent, you would know cosecant, secant, and cotangent. Some people get the cosecant and the secant mixed up. They think that sine and secant should go together and cosecant should go together because those don't have cos and those do. But when you're thinking about the reciprocals, I always think in my mind, like they can't start with the same letter. That's how I remember it. Like, okay, sine is not going to be with secant. They start with the same letter. So that's just, I mean, there's no mathematical principle there. I just use that to remember it in my head. Sine is with cosecant, cosine is with secant, and tangent is with cotangent. Okay. So we're going to be given a triangle, and we're going to write down all 6 of the trig functions. We'll use our most famous Pythagorean triple. Those are ones that have whole numbers on all 3 sides. There aren't very many of those. So before I write down all 6 of my trig functions and plug it in, I need to label which side is opposite, which side's adjacent, which side is hypotenuse, just so you don't get confused when you're using this. So my theta is this angle here at the top, so it's going to be a little bit different than the triangle we just drew. But what is 5? What side is 5?
Hypotenuse.
Hypotenuse, right? It's across from the right angle. It's the longest side. So this is the hypotenuse. What is 4 in reference to the theta? It's the opposite side of theta. It's the opposite of theta. And 3 is the adjacent side. Okay. Your theta will always be made up of the hypotenuse and the side that's adjacent to it. So those 2 lines there will always be hypotenuse and adjacent, where you have your theta, and the one that's across, that's your opposite. So we're going to write down all 6 of our trig functions. So sine theta, cosine theta, tangent, cosecant, secant, and cotangent. I always put them in this order so that it's really easy. Once you've done the first 3, you just flip them over to get the other 3. So sine is opposite over hypotenuse, and those numbers are 4 over 5. Cosine is adjacent over hypotenuse, so that would be 3 over 5. Tangent is opposite over adjacent, which would be 4 over 3. And then to get your remaining 3, we just flip the other ones over. So y'all fill out the second column. Then we'll check and make sure you got them right. Okay, so we should have gotten 5/4, 5/3, and 3/4. Everybody okay there? We'll do one more where we have to find all 6 of our trig functions, but in this case, they're not going to give you all 3 sides. They're only going to give you 2 sides. So we have to remember how to find the 3rd side of a right triangle.
Isn't it? Okay, never mind.
Are you going to say the Pythagorean theorem?
Yeah.
Yep, that's right.
Yay.
All right, so before we can plug in our numbers into our trig ratios, we need to figure out what our remaining side is. We know that the Pythagorean theorem is a squared plus b squared equals c squared, and the c is always the hypotenuse. So I've got my a, I don't have my b, and I do have my c. So I would say, oops, I wrote a instead of 5. 5 squared plus b squared equals 6 squared. Go ahead and write what these are squared. We're trying to get the b by itself. So we subtract the 25. What's 36 minus 25? 11. Yep, so b squared equals 11. Then if you want b by itself, you've got to take the square root of both sides. So b is the square root of 11. If it's not a perfect square, just leave it in the square root sign. So we're just going to put for this side, square root of 11. So now we're going to write which one's hypotenuse, which one's opposite, and which one's adjacent before we fill it in. So 6, what is 6? That is the hypotenuse. 5 is the opposite, and square root of 11 is the adjacent in relation to the theta that we have here. Okay, then we'll fill them in, and if we need to rationalize the denominator, we will at the end. Both side is opposite over hypotenuse, 5 over 6. You can go ahead and do cosecant at the same time if you want. Cosine is square root of 11 over 6. So this would be 6 over square root of 11. Tangent is opposite over adjacent. Thumbs up if you're okay with the number placing in the spots. Okay. All right. Remember, we don't leave square roots in a denominator. Do you guys remember what to do if there's a square root in the denominator? We do the same square root on top and bottom. So we'll put root 11 like this on top and bottom. So that would end up being 5 root 11. And when you do the square root by itself, multiplied by itself, you just end up with the number on the inside. So that's 5 root 11 over 11. And what other trig ratio do we need to do that on? Secant. So we need to do that on secant as well. So you just put root 11 on top and bottom. So that one is 6 root 11 over 11. Sorry if you're still writing that. Raise your hand if you remember these special right triangles. If you remember hearing about special right triangles, that maybe that happened in geometry, or was geometry just so far away or so long ago you just don't remember? That's what I'm getting some eye rolls of, oh, nope, got nothing. So
I failed geometry, so.
Okay. Have you gotten your credit yet? You gotta do that to graduate.
Yeah, I did.
Okay. We have two special right triangles, the ones that we use so much and the ones that actually have like a cool pattern just based on the way that their numbers are. The first one is when you have two of your A and your B, or your two sides of your right triangle are the same. They have a special pattern that can apply to all of the things. So if our two sides are the same, our two angles are going to be the same. That would be in a 45, 45, 90 triangle. And our sides are the same. We always put X's on those because whatever that side is, this is the other side as well. And when you use the Pythagorean theorem to try and figure out what your hypotenuse is, it's kind of neat that it ends up being whatever X is times the square root of 2. When you solve for your C, that's what it ends up being. So it ends up being X times the square root of 2. So if you have a 45, 45, 90 triangle, it's always going to follow this pattern. If you know what one of your sides is, like if this was 5, the other one would be 5, and your hypotenuse would be 5 root 2. Okay, if this was 4, this would be 4, and that would be 4 root 2. So if you know it's 45, 45, 90, you don't have to use the Pythagorean theorem to figure out your third side of your triangle. You can just use this pattern. So we're going to apply this pattern to figure out what our trig ratios are for 45 degrees, because we use 45 degrees all the time. It's one of our important angles. So what I like to do is I don't want to use X's when I write my ratios because that's going to get messy. So I'm just going to plug a 1 in for all of the X's and then do sine, cosine, and tangent on that. So just so we get these. So we'll do it like this. Just going to plug a 1 in, 1, 1, and then 1 root 2. I don't have to put the 1 in front. So it's the same thing that we just did. It's just a pattern that we use all the time, and we'll use this a bunch. Sometimes instead of being asked in degrees, like sine of 45 degrees, you might be asked in radians. 45 degrees, that is the same thing as pi over 4. So if you get asked about it, pi over 4, sine of pi over 4, that's the same as sine of 45. All right, so let's label our O and our A and our H. It doesn't really matter about the O and the A because they're the same, right? If I did it from this 45-degree angle, there would be both be one, same thing from that angle, but I'll just pick this one just so we can mark it. It doesn't really matter though. This is the opposite, the adjacent, and the hypotenuse. So I'm just going to go around the room, just kidding, go around the boxes and just going to ask you guys to tell me what these trig functions are. And then if we need to rationalize them, we will. So let's start at the top with Shelby. Sine of 45, that's our opposite over hypotenuse. So what's that going to be? Oh, Shelby, are you there? Okay. Opposite over hypotenuse.
So it's going to be 1 over square 2.
Yep, 1 over square root of 2. So go ahead and help me do cosecant.
Square root of 2 over 1.
Okay, so good. We do need to rationalize the first one. So we do root 2 on top and bottom. So that ends up being square root of 2 over 2. And we don't really need the 1 on the bottom of the cosecant. It can just be written as square root of 2. Diego, can you help me out with cosine? It's adjacent over hypotenuse.
One over square root of 2.
Okay, and then the secant?
Square root of 2 over 1.
Okay. And rationalize is the same way, so I'm not going to write it next to it. So that's root 2 over 2. And this would simplify to simply root 2. And Alan, tangent and cotangent. It's our opposite over adjacent.
1 over 1.
Mm-hmm. And then the other one?
1.
Yeah.
It's just 1.
So just 1 for both of those. All right, so now we know our 6 trig functions for 45 degrees or pi over 4. So if anybody asked you those, you don't have to use a calculator. You'll have to have exact values anyway. The calculator doesn't really help you. But you could say, oh man, I forgot it. But I can draw my triangle and put my 1, 1, root 2 and figure it out if you forget what these are. We're going to use them so much that you'll probably start to memorize them. So that was 45, 45, 90. We have one other special right triangle. Does anybody remember what it is? Just going to assume no at this point with the right triangles. It's been 2 years and a pandemic. So we have 30, 60, 90. So you've got one of your angles is 30 degrees, one of your angles is 60 degrees, and one of the angles is 90 degrees. The 30 is across from the short side, the 60 is across from the medium side, the 90 is across from the long side. And your pattern, X is across from the 30, 2X is across from the 90, and across from the 60 is X root 3. So that's what you would have learned in geometry. Now we're going to plug in ones for the x's to make it a little bit more simplified for us to do our trig functions. We're going to do trig functions with 30 degrees, and also we'll do one with 60 degrees. So we're going to do 2 sets. I'll make my triangle. So the opposite and adjacent will switch depending on which one we're doing. So we do 1, root 3, and 2. Here's our 30 degrees and our 60 degrees. You know, Miss Sheffield had that stamp for graphs that she would graph on the little things. I wish there was a stamp for the 6 trig functions that you could just stamp those without having to write it every time over and over again. That'd be nice. All right, then we do the same thing that we just did. We'll look at 30 degrees and we'll see that 2 was the hypotenuse. For 30 degrees, 1 is the opposite and root 3 is the adjacent. Y'all go ahead and write out these 6 trig functions. Do your opposite over hypotenuse, adjacent over hypotenuse, and we'll make sure that they're right. So do that quickly, and I'll set up the 60-degree stuff. If you finish the 30 degrees and want to do the 60, that's fine. It's just your opposite and adjacent switch because we were using the angle on the bottom instead.
So, well, you'll explain it. I'll just wait.
Okay. All right, let's check the 30 degrees. So sine of 30, that's opposite over hypotenuse, which is 1/2. And cosecant is the reciprocal, so that's 2 over 1, which just simplifies to 2. Everybody okay on sine and cosecant? First row? All right, our second one is cosine. So that is going to be adjacent over hypotenuse, which is √3 over 2. The reciprocal would be 2 over √3, which we need to rationalize. So 2 √3 over 3. And tangent is opposite over adjacent, which would be 1 over √3. And I'm going to go ahead and do the reciprocal, then I'll rationalize. So √3 over 1. So we do √3 on top and bottom, and it just ends up being √3 over 3.
What about cosine 30?
Cosine 30, that was adjacent over hypotenuse, which is √3 over 2. If the number on the bottom isn't the square root, you don't have to do any rationalizing. It's just the ones on the bottom.
Wait.
So my question was gonna be on like tan 30, when you make it right or whatever.
Yeah.
On cot 30, do you use what you did or do you use the original?
I would use the original because if you used what you did, you would end up with a √3 on the bottom and have to rationalize that again.
Yeah.
So I'm going to go ahead and put that one on the top here and not have to worry about it.
Gotcha.
Yeah. You'd get the same answer. It just takes a couple more steps to get there. The step's going to simplify and you just end up with that. But all right, so let's go ahead and now we're going to do the 60 degrees. So the thing that switches is our adjacent and our opposite. So now for 60 degrees, opposite is √3 and adjacent is the 1. So 60 opposite over adjacent would be √3 over 2, which is just the same as cosine of 30. And since I already know what that's going to be rationalized, I'm just going to write it down. Just save myself a little bit of time. Okay, cosine of 60, adjacent over hypotenuse, 1/2. Flip that over and you get 2. Tangent is opposite over adjacent, which would just be the √3 over 1, or √3. And adjacent over opposite was the 1 over √3, and we already rationalized that up here, which is √3 over 3. So everything that we did in the 30 degrees, matches the 60 degrees, it just swaps with the co. So sine and cosine swap, secant and cosecant swap, and tangent and cotangent swap. So if two angles, this is just kind of a cool thing with triangles, if two angles add up to 90 degrees, like 30 and 60, or even like 20 and 70, the numbers are going to match. The codes are just swapped. So if you knew one of them, you could just trade it for the others. So those just swap, these swap, and these change.
Can you scroll back up to the top real quick to the right there? Down a little bit. I could have sworn that we had rationalized the top end and the bottom when we did it.
Oh, right
Like
here?
Yeah.
No, it was only when it was on the bottom. The ones on the top, we just kept them there.
But on the 10, oh, okay. So you don't rationalize the top,
No.
just the bottom.
Yeah, it's called rationalizing the denominator. It's like the full name of it. That's the bottom part.
Okay.
Okay. And then our very last thing for today is to solve all of the pieces of a triangle. So we're going to put into place what we know about our trig functions and what we know about angles adding up to 180. So they're going to give us some of the pieces and we have to find all of it. So at the end of it, we want the length of all the sides, and also we want the angle measures, all three angle measures. So this section is really about finding 6 parts of everything, really, to solve triangles. So what we want to do is we want to figure out what the two sides are that we don't know, and also the angle is that we don't know. So for this, I always write down all 6 of the things, the 3 angles and the 3 sides, just so I know what I need to fill in. In case you guys forgot, the lowercase letters represent the side that's across from that angle. So like a capital B across from that is a lowercase b. A capital C across from that is a lowercase c for the side. Capital A angle across from that's a lowercase a for that side length. So we don't know angle A yet, but we know angle B. Angle B is 90 degrees. Angle C is 30 degrees. And we know that side B is 10. So we're going to figure the rest out. I'm pretty sure we can do angle A pretty quickly. All right, we got 90, we got 30. What's angle A have to be?
60.
Yep. 60 degrees. Okay, and then there's 2 different ways that we could do this. Since this is a special right triangle, 30, 60, 90, we can apply our pattern if we want, or we can use our trig ratios. I like to use the trig ratios because it makes more sense. I don't have to memorize the pattern. So I'm just going to think, I need to know side A. I only have one side, so I can't use the Pythagorean theorem. I'm going to use I need side A, but I also am going to have to use the side that I know. All right. So I'm looking for A. I know 10 and I know 30. So when I'm looking for this, these are the things that I know. This is what I'm looking for. So I want to know what trig ratio I should use. Would this be my angle? And I've got an A and a C. So this is an adjacent and a hypotenuse. So which one should I use?
Cosine.
Yeah, cosine. So cosine of 30 equals adjacent over hypotenuse, which is a over 10. So I'm going to write that out and we'll solve it in a second. So cosine of 30 equals a over 10. And now if I'm doing C, I'm still going to use the stuff that they gave me. The angle they gave me, the side they gave me, and then I'm looking for C. So in this case now C is opposite and 10 is hypotenuse. So which trig function would you use?
Sine.
Yeah, so opposite and hypotenuse, that's going to be sine. So sine of 30 degrees equals C over 10. So you just identify what you want, what you have, and if that's going to be sine, cosine, or tangent. Okay? Since 30 degrees is from one of our special right triangles, we can go back up in our notes and see what cosine of 30 is and what sine of 30 is and just replace them. Because that works for any triangle that has 30 degrees in it. It's going to have the same cosine and the same sine. So let's go back up to what we just did. What was cosine of 30?
Square root of 3.
Square root of 3 over 2 for cosine of 30. That's the same as square root of 3 over 2. Okay, and sine of 30 was 1/2. So when you have 30, 45, or 60 in your problems like this, you don't have to use a calculator. You can just go back and say, oh, what was that? We already did that already. All right. And so if I want A by itself, I'm going to multiply by 10. So that's 10 root 3 over 2. And does that simplify? 10 over 2 makes 5. So A is 5 root 3. And then multiply by 10 on the other side. That would be 10 over 2, which is C, and that is just 5. So A is 5 root 3, and C is 5.
Does it get any more complicated than that?
We're doing one more, and you have to use a calculator, but that's all. These are the ones you just have to look at your notes and say, oh, I know 30, 60, and 45. I can do that. But the next ones you have to put in the calculator. And you have to make sure that if the problem's in degrees, that your calculator is also in degrees.
I didn't get all of it.
Sorry. That better?
Yes.
Let me go that far down. Okay, so on this one, this is what we are given. And angle A is 14.35, angle B is 90, side A is 12. So to get angle C, we want to do that first, just so we'll have it on here. Angle C, we do 180, right? Or 90 minus 14.35, because those two sides add up to 90. You could subtract it all from 180 if you wanted to. So we just found that C is 75.65 degrees. subtract 180 minus this and this to get that. They all add up to that. Now, which side do you want to find first, B or C? Does it really matter? Okay, let's go with B then. So here's the angle that I've given. This is what I'm looking for. This is what I know. So from this angle, I have opposite and I have hypotenuse, which would be which trig ratio? Opposite and hypotenuse, that would be
Sine.
sine. So sine of 14.35 degrees equals 12 over B. Now let's write what we're going to do for the C down. So I've got opposite and also adjacent. That's going to be
Tangent.
tangent. You could use cotangent or you could use cosecant on this, but there's not that button in the calculator, so I normally stick to the main three. Otherwise, you have to, I don't know how you could find them otherwise. All right, so we're going to write out what B is going to equal. We're going to solve for B, and then we'll put it in the calculator. So if you want to get B out of this denominator, where does it need to go? What do we need to do with it? We're trying to solve for B. We're going to multiply it on the other side. So B sine 14.35 equals 12. Is the B by itself yet? No, we need to divide the sine to get it by itself. So 12 over sine 14.35. And the same process over here. Multiply by the C and then divide the tangent to get the C by itself. So for these, we make sure on our calculator we are in degree mode. Type in 12 divided by sine 14.35 and write down our angle measure and then our side length, and then we do it for the other one. So you use your trig ratio to set up your equation, and then you solve for your variable, and then put that in the calculator. Any questions about these? Most of it's a review from geometry, but that's been a while, so. Go ahead and get started working. If you have questions, let me know.